Okay, welcome back. Geography 101, Chapter 18. This is Geography of Soils, and it's really good stuff. People are not all that interested in dirt, but to me it ties together a lot of what we've looked at in terms of geology and climate. And to me, this is extremely important if you want to understand why the world is the way it is. One of the places you got to start looking at is dirt. Here are some of the learning objectives. So the science of dirt is called pedology, or the soil scientists, and we don't have one in this department, but maybe geology has one. Sometimes they're in forestry or some of the other departments. And if you're a pedologist, you would study dirt, essentially, where it is, how it gets to be the way it is. A pedon is this hexagonal column, and we'll look at a pedon here and there. And it's a soil sampling unit. It's a way of gathering a sample of soil in order to study it. Together, if there's a number of pedons, it's a polypedon, and it's the basic unit of mapping for soil maps. This is a pedon, and here are the horizons, which are a sort of a fancy way of saying layers of soil. And we will ask you to know a little bit about soil horizons. So at the top is the O horizon, and O comes from really organic. It's where a lot of the dead plants and occasional dead animals are undecomposed yet, and is generally a very dark layer. The A horizon, just or below it, I should say, has some of the leached material with a high proportion of the organic material that has been decomposed, and it's also very dark layer. So let's take a look here. The O layer would be this very top one, and then the A layer is sort of this darkish area just below it. The E layer comes next, and that has eluviation, as you're going to see, and it's a lighter colored layer, and this is the area of maximum leaching. Leaching is an important word that refers to the downward movement of soil particles and soil chemicals through the soil horizon. The B horizon comes after the E, and it's the maximum zone of accumulation of weathering products. So the clays, irons, aluminums, humus, which is not the stuff you eat, but is the word that refers to sort of the detritus of decomposition. Carbonates, gypsum, silica, all of those things are eroded, made into tiny particles, all the way down to compound size, and they leach downward and accumulate in the B horizon. The C horizon is basically a bunch of rocks that are from the parent material. They're broken up, and then below that is the parent material itself, known as the bedrock, and it has an R for regolith, which is essentially the broken rock of the bedrock. The A horizon to the E horizon, that's the alluvial zone, and the B horizon is the illuvial zone. So stuff is leaching downward through the alluvial zone, and where it stops or accumulates is the illuvial zone. The A plus E plus Z zones is Sulum, and that is a soil zone that can be defined. So, soil properties, there's a number of them. We'll start with color, move on to texture, structure, chemistry. We won't talk too much about that, but we'll get through to that in this segment. And a lot of that soil chemistry has to do with the acidity of the soil, which is important to farmers and is a product of all sorts of things. Soil color, if you're in one of the labs, you may do a soil color analysis by using a Munsell chart. This is kind of a nutty thing. It was developed for other purposes in 1913, but you get this color palette with holes in it, and you put it down over a sample of your dirt, and you can then compare the dirt that you have or the soil to various hues, values, and chroma, and each of the colors on that Munsell chart has a name. It's like a great big paint swatch type thing from the Home Depot, but it's used to evaluate the color. Once you've got the color down, you begin to ask questions about the soil texture. So soil is all made up essentially of three types of material: sand, silt, and clay. Within any particular pedon or soil sample, there will be a mix or sand, silt, and clay. If it's all clay, it would be up here on the soil texture triangle. If it was all silt, it would be over here. And if it was all sand, it would be over here on the soil texture triangle. Most soils are somewhere in between, and some of this area over here, the sandy loam or loamy soils, are what farmers really prefer, and we'll take a look at that. What is sand, silt, and clay? Well, if we were to take a photo of all three using, say, a microscope, then we would see this distribution. Coarse sand, the kind that you frequently find at the beach, is this size here in yellow, and then you have medium sands and fine sands, and you may know those from sandpaper if you have bought sandpaper at a Home Depot or something like that. Silt and clay, much smaller. Clay particles, which are represented only by that little speck there, the smallest by a long shot. Silt, which is very fine itself, goes from 0.002 to 0.05 millimeters in size, so 1/2 of 1/10 of a millimeter is silt, and sand ranges from this 0.05 millimeters all the way up to 2 millimeters in size, which would be a really coarse sand. And above that, then you get what we'd think of as gravel, and then gravel is 2 to 75 millimeters, and rock is above 75 millimeters. For a conglomerate store, one of those kind of places that will sell you sand and rock and gravel for your landscaping needs, all of these things are well known. The composition of sand and clays and loams have a lot to do with the hydraulic characteristics. Basically, how does water move through the soil? So which soil between sand and clay drains faster? Sand, definitely. And which holds more water? And that's clay. And so a really sandy soil is not very good for farming because it won't hold enough water for most plants. And then a very clayey soil that has too much clay holds too much water and can waterlog and drown plants. So that's why somewhere in between the two becomes very good. Sand, very easy to plow. Clay, almost impossible to plow, but you need some of both in high quality agricultural soils. Loam is that mixture, and that's what you really would like to do. Sandy loam, easy to plow, but with some clay that holds water, is really outstanding. And this idea here is really important to understand for the history of the United States, or any other country for that matter, because different ethnic groups had different preferences for soil types based on where they had come from in Europe or other places. Those people who understood what type of soils had the best characteristics wound up being more prosperous than those who didn't understand that when they arrived here. And then we have soil structure, which defines the size of the soil particles and how it comes together, how they're arranged. These very small lumps of soil are called PEDs, and the shape of PEDs depends on how they break apart essentially in your hand. You can have a very fine PEDs, medium or coarse PEDs, and here's what they look like. This crumb or granular PEDs are the kind that you would like to have clumping together just a little bit in your hand, and this is ideal for agriculture. You get some of these others that have too much clay in them, and they tend to be platy, meaning plate-like, and break off in sheets, or blocky, break off in chunks that all would be very hard to plow or to work. And then you can even get prismatic or columnar, which break off in columns. Soil chemistry refers to a number of things. Water in the soil pores is the soil solution, and so you can draw water from the pores in the soil to get the soil solution. We won't go too much into the chemistry of all of this, but I thought I would throw a couple of these slides up here so you can be reminded of this. Here is the important part. The soil that has a lot of hydrogen ions in it is an acidic soil, and a soil with a lot of base cations, calcium and sodium, is basic, or we usually talk about alkaline or alkali soils, particularly here in California. Here's the pH scale. So if you have really alkali soils, they'll be whitish, and they have a lot of salts and that sort of stuff out here in the desert, and you can see them just driving past. Those are alkali soils, and they have to be conditioned in order to make them very useful. And then in humid regions, you have acidic or peaty soils, and they can be over here, and you have to add lime to them in order to make them behave better. These neutral soils somewhere in the middle are ideal for agricultural purposes. When acid rain falls from the sky, that can raise the soil acidity up to the point where it can be unusable for agricultural purposes. Some measurements have even found these acid rain infected soils at below 2.0, which puts it well beyond vinegar that would be way down in the acidic peat soils. It also accelerates the decomposition and weathering of mineral nutrients, and then depletes the soil at a very high rate. Soil that is just below 6.0 needs lime or calcium carbonate put into it, and you will find that gardening soils, but also farmers buy it in industrial parts. So let's stop there in this segment.